Hello and welcome to the new episode of GeoProspectors webinar sessions. My name is Tibor and I'm the data analyst by GeoProspectors. In the next couple of minutes, I'm going to show you some use cases, let's say real-world examples, how you can use Topsoil Mappers data products. So let's see. During our sessions of sales process or technical trainings already, we are getting frequently questions about agronomical interpretations of the scanning data. uh, Users are all the time having in their mind in the future how they can use the system. Of course, that's obvious. That's almost the first question which is coming up in your mind. Uh, Therefore, I was putting together a data set where I can showcase you from EC scans, so from the scan data, how can you do a proper soil sampling. From this soil sampling, how can you plan your variable rate fertilizations? And I was planning it for corn. Our dedicated processing software is also capable to calculate variable depth tillage and also variable rate seeding. For this actual field, I was planning the seeding for corn. So let's start with the first use case, namely from EC scan to soil sampling. In this example, I'm going to show you how you can interpret soil EC data, how you can scan, how you can plan your management zones, and how you can take your soil samples and at the end take your soil samples to the soil laboratory. Management zones based on EC data giving you the best result for treating your soil on your best way. So let's see step by step how we can get our soil sampling maps right out from the EC scannings. First of all, we have to attach the scanner to our towing vehicle and execute scanning. This towing vehicle can be a pickup, can be a quad bike, can be a side-by-side, or even can be a tractor, also for scanning as well, not just for online control. Right after scanning, you can immediately download the files from the terminal and import it to our dedicated software called FMS, where you can analyze the data, and right after that, immediately check your results. In 4 different depths, you can see the conductivity data. The first, the shallowest coil data, is about 15-20 centimeters, and the other following 20 centimeters incremental. With a button push, you can immediately calculate also the ECA zone map, where you can also see the low and high values for conductivity. This map is going to be the base for our soil sampling map. As a next step, we are ready to assign our sampling points from our calculated ECA zones. Please check our other videos as well, where we are explaining how you can select based on your field size your best fitting sampling method. For this actual field, I was using the buffer sampling method. If we decide to collect soil samples based on EC zones, we can expect that in the same soil zone or EC zone, we are going to have roughly the same soil texture, roughly the same total dissolved solids, and roughly the same water content level. Most probably at least once, you are going to verify the connection between the ACA sampling and the laboratory results. The best way to validate the dataset is to check the total dissolved solids from the laboratory results. On the internet, you can find several researches which is confirming the close linear correlation in between the soil apparent electrical conductivity and the total dissolved solids. Therefore, in the spots where you have high conductivity, you also have to have high total dissolved solids. In this example, you can see clearly that the conductivity and the total dissolved solids are completely matching. Once we have finished our data validation, we are ready to take the next step for variable rate fertilization for corn. In order to create our prescription maps, it is essential to have our soil sampling results, lab results, and the third-party software. This third-party software can be a farm management software from different sources. And of course, a normal GIS software also can be used. We are taking our sampling points and we are assigning for our elements what is the current availability of nitrogen, phosphorus, and potassium. From the current availability maps, it is really easy and quick to calculate our application maps. In the most common farm management softwares, there are built-in algorithms where you can enter your thresholds, minimum and maximum values, and it is going to adjust based on the availability maps, the final application map. With GIS software, it is a little bit different. First, you have to invert your values and then assign your minimum and maximum values for the different fertilizers. If you follow this procedure, you can be sure that your field is prepared on the best way for the crop season. Again, since all your fertilizing actions are not planned on vegetation, it is planned on pure soil conditions and proper laboratory results as well. Continuing our exploration among topsoil mapper data products, the next step I would like to introduce you the variable depth tillage. Based on the same field, I was calculating a tillage map too. It is important to highlight here that we have two different ways to implement tillage maps on our equipment. One is the full online control, where we are using the topsoil mapper together with the automatic tillage control kit. In this way, the topsoil mapper operates the tillage equipment on the fly, full online control, and you can set up three different possibilities to operate: shallow cultivation, subsoiling, and contour profiling. During shallow cultivation and subsoiling, the tillage depth will be set based on the corresponding ECA coil. For shallow cultivation, the first two coils will be used, and for subsoiling, the second and part of the third coil will be taken into account. For contour profiling, the depth to interface values will be taken into account. On the ISO terminal, we can also find an invert button where we can invert all the values. So the factory defaults are with high EC values, we are going to go shallower, and with lower EC values, we can go deeper. And this behavior can be inverted with this button. Using the offline control without the topsoil mapper, you have to use the FMS software again, where you have all the previously mentioned functions, and basically you can make the same prescription maps using the same previously mentioned functions for also offline control of your tillage equipment. So again, for offline control, the first step what you have to do is scanning. Second step is to upload the scan for the FMS software, calculate your prescription map for tillage, and then you can upload it to your ISO terminal and using it without the topsoil mapper. This can mean that you have only one scanner and, for example, 50 ATC kits, then you can execute all the tillage activities with these 50 ATC kits bolted onto 50 different tractors at the same time. The only limiting factor can be that fields have to be recorded previously, processed, and tillage ISO XMS must be uploaded to the tractors. Therefore, based on farm size, time schedule for scanning and processing can be tough. In these cases, acquisition of additional topsoil mappers is highly recommended. Checking back to our sample field, I copied here the depth to interface map where all depths were confirmed with a penetrologger. In this case, depth to interface values represents the top of a 2 cm thick plow pan. The tillage map on the right has been calculated using the shallow cultivation algorithm with keeping an eye on the depth to interface map with the revealed plow pan. This resulted the fine-tuned prescription map where our plow pan will be destroyed, as well as tillage depth adjustments resulting in optimized fuel consumption. Please have a look comparing the depth values, how precise the algorithm has been calculating them. Low EC values representing a looser, while high EC a denser soil texture. Bringing in the F2 interface values to the scene you are able to cultivate your soil in a highly cost-effective way with the highest level of agronomical benefits. As a final spot of the webinar, we arrived at the design of the variable rate seed prescription map of our sample field. Of course, as I mentioned earlier, planned for planting corn. The usage of the VRS function quite resembles for the tillage function. There is an online as well as a map-based control. For the online control, you need to attach the topsoil mapper to the front of the tractor. Based on the shallow STC data, relative water content, and some additional parameters such as elevation, slope, depressions, the sensor calculates the seed rate. Through isobus, it sends the data stream in order to control on the fly your planter. The make of your VRS prescription maps for offline control in this case does not differ too much from your usual preparations. The main difference is that VRS maps are made in the FMS software and exported in shape or ISO XML format to your seeder. It is obvious that to be able to make this happen, you need to first scan your field with the topsoil mapper. But this gives you the advantage, like by the offline tillage, that you can use precise VRS maps on multiple seeders simultaneously. As a factory default, TSM controls the planter by low conductivity, lighter soil, lower seed rate, while with the higher EC values, it controls higher seed rate. This approach can be inverted by the online control as well as by the offline. Thank you for your attention and stay tuned for the next session. If you have any questions, thoughts, ideas, please leave your comments below, or you can also reach us on any of our social media channels like Facebook, Twitter, Instagram. See you soon.